Any realistic military analysis of a potential large-scale invasion of Russia in the 2030 era does not begin with weapons, armies, or battlefield tactics. It begins with the fundamental physics of the land itself. It begins with a structural question. Can modern military power overcome geography, logistics, and strategic depth at continental scale under conditions of full-spectrum warfare? Because if the answer is negative, then the concept of invasion itself becomes non-viable. Regardless of technological superiority, certain physical constants remain. The first and most fundamental constraint is scale. Russia is not simply a large territory. It is a multi-theater strategic environment spanning 11 time zones, from the European plains to the Siberian wilderness and the Arctic periphery. This creates what military analysts refer to as layered operational depth. In simple terms, there is no single decisive battlefield. There is no singular capital capture scenario that guarantees systemic collapse. There is no geographic bottleneck that ends resistance. Instead, the entire country functions as a distributed defense system across vast distances. Historically, warfare has often depended on the concept of center of gravity, a critical point whose destruction collapses the enemy structure. But in Russia's case, the system is deliberately designed to avoid this vulnerability. Industrial capacity is distributed across multiple regions. Military command structures are decentralized. Critical infrastructure is redundant and geographically dispersed, creating resilience against precision strikes. So even if an invading force achieves early tactical success, the strategic system continues functioning. This leads directly to the second constraint: logistics at continental scale. Modern warfare in 2030 is fundamentally logistics dependent. Even the most advanced military forces rely on continuous supply chains involving fuel, precision ammunition, spare parts, and maintenance cycles. Once a force moves beyond a certain operational depth, efficiency begins to degrade, typically estimated as a few hundred kilometers beyond secure staging areas. In the case of Russia, invasion routes can extend thousands of kilometers. This creates exponential strain rather than linear strain. Each additional unit of distance does not simply add difficulty, it multiplies complexity. Supply convoys become longer, more vulnerable, and harder to protect. Repair cycles slow down due to transport delays. Battlefield units begin operating at reduced readiness levels as command structures lose synchronization. This is not hypothetical. It is consistent with historical precedent, from Napoleon to Barbarossa. During the French invasion, the force entered with one of the most advanced military systems of its time. Initial movement was rapid, but logistical overextension became a decisive factor long before direct military defeat. The campaign collapsed due to systemic overstretch. Similarly, during Operation Barbarossa, early advances covered massive territory. Yet the German military structure gradually degraded as supply lines extended beyond sustainable limits. The critical insight is that neither campaign was lost primarily through battlefield defeat in the early phase. Both collapsed due to systemic overstretch. In 2030 conditions, this principle becomes even more pronounced. Unlike historical armies, modern forces rely heavily on digital infrastructure, satellite navigation, real-time reconnaissance, and AI-assisted targeting systems. This introduces a second layer of vulnerability: digital dependency. A disruption in satellite coverage or cyber interference does not merely slow operations, it fragments coordination entirely. A force that cannot coordinate at scale ceases to function as a unified system. It becomes isolated units operating independently under degraded awareness conditions. Russia maintains one of the most developed electronic warfare ecosystems globally, designed to remove informational certainty. It becomes isolated units operating independently under degraded awareness conditions. Russia maintains one of the most developed electronic warfare ecosystems globally, designed to remove informational certainty. In a modern scenario, this removes informational certainty. And in modern warfare, uncertainty is strategically decisive. Success requires stability across too many variables. Winter conditions introduce sustained sub-zero temperatures that affect machinery performance, fuel stability, battery life, and human endurance. Snow coverage reduces mobility and visibility simultaneously. Spring and autumn create the Rasputitsa phenomenon, periods where terrain becomes saturated with mud, effectively disabling heavy mechanized movement across large areas. These are not occasional disruptions. Spring and autumn create the Rasputitsa phenomenon, periods where terrain becomes saturated with mud, effectively disabling heavy mechanized movement across large areas. These are not occasional disruptions. This creates a fundamental timing constraint on any large military operation. Campaign success becomes dependent not only on enemy resistance, but on environmental alignment. Then there is strategic doctrine. Unlike conventional military models that prioritize decisive engagement, Russia's defensive structure is historically built on strategic depth and attritional absorption. The purpose is the temporal extension of conflict. In strategic terms, this forces the invading power into a war of endurance rather than a war of maneuver. And endurance warfare is structurally disadvantageous for any force operating far from its base. This approach reduces the effectiveness of rapid offensive doctrines such as blitzkrieg-style operations, which rely on speed and concentration. When the battlefield expands beyond logistics range, speed loses its value. This approach reduces the effectiveness of rapid offensive doctrines such as blitzkrieg-style operations, which rely on speed and concentration. When the battlefield expands beyond logistics range, speed loses its value. This pattern is not accidental. It is structural. Once these problems are established, the analysis moves into a far more complex domain. Modern warfare is no longer defined only by land control. It is defined by system disruption, and in that context, escalation does not remain confined to the battlefield. It expands into infrastructure, information networks, and strategic deterrence. By 2030, conflict between advanced military powers involves continuous integration of satellites, drones, cyber operations, and AI command systems. This creates a battlefield that is layered and simultaneous. A single disruption in one domain can cascade into failures across all others. Interference with navigation affects logistics routing, drone coordination, and battlefield situational awareness. Control of information is paramount. Russia maintains significant capability in electronic warfare designed specifically to degrade adversary coordination. This introduces a key asymmetry. Advanced systems depend on stability, but instability accumulates. The sixth constraint is infrastructure vulnerability. Modern militaries depend on continuous external supply systems. In a prolonged campaign, these systems, fuel networks, power grids, and hubs, become primary targets. Infrastructure warfare aims to reduce an army's ability to function. In the Russian theater, the spatial distribution of infrastructure means disruption must cover massive areas to be effective, creating a high-cost environment. Partial disruption produces limited operational delay but does not eliminate systemic capability. This leads to the seventh constraint, escalation dominance and the shadow of nuclear deterrence. A modern invasion involving Russia cannot be evaluated purely at conventional levels. It must include nuclear deterrence architecture, one of the largest arsenals in the world, ensuring retaliation even after damage. This creates an existential escalation risk. Any large-scale invasion extends into national survival risk assessment, altering decision-making logic as escalation thresholds are approached. Escalation is discontinuous. When all these factors combine, scale, logistics, environment, and doctrine, the result is a structural condition where conventional invasion logic no longer produces reliable outcomes. In Part 2, we explore the final systems of collapse. Stay tuned for the second half of our investigation into the structural impossibility of invading the unconquerable land. Is only the first layer. To truly understand why an invasion of Russia is structurally non-viable, we must look at the secondary and tertiary systems that support a nation's ability to endure under pressure. The eighth constraint is economic endurance. Modern wars are not only fought on battlefields with steel and lead. They are fought in factories, banks, and the domestic economic structures that sustain a total war effort. Unlike many modern economies, Russia's industrial heartland is deliberately placed in its strategic interior. Beyond the reach of most conventional strikes, the Ural and Siberian industrial zones provide a redundant backbone. This industrial system is connected by a vast internal railway network. While vulnerable to disruption, its sheer scale and redundancy mean that total paralysis is nearly impossible at continental scale. This is paired with fundamental resource independence. In energy, grain, and raw minerals, the Russian state operates from a position of relative autarky compared to any invading force. The invader must ship every liter of fuel and every kilogram of supplies across a hostile continent. The defender, however, draws from a well that is literally beneath their feet and within their own borders. This creates an asymmetric cost ratio. The cost of maintaining an invading force in the field increases exponentially with time and distance, while the defender operates on internal lines of communication. Historically, this has forced invaders into economic collapse long before their military was defeated. A state that cannot pay for its war cannot win its war, especially when the goals remain elusive. While external pressures can degrade a defender's economy, they often fail to collapse the system if it is rooted in deep domestic resource extraction and a command-driven wartime economy. The ninth constraint is internal political sustainability. Large-scale military invasions are high-risk political ventures. They are not sustained by tactical success alone, but by the will of the public. As conflict duration increases and territorial gains fail to translate into strategic resolution, political support erodes. The short victorious war becomes a multi-year quagmire the public did not sign up for. This is the victory problem. In a country with Russia's depth, what does victory look like? Capturing a capital that has been emptied. The lack of clear victory conditions is a political poison. This creates a secondary pressure layer. Even successful tactical operations may fail to produce strategic justification for continued escalation, leading to internal political fractures. Invading coalitions also face the pressure of time. Alliances are built on common interests, but long-duration, high-cost wars inevitably create friction between partners, leading to strategic fragmentation. There is also the psychological cost of the landscape itself. The sheer scale and harshness of the environment create a sense of isolation that breaks the morale of occupational forces. The 10th and final constraint is cumulative system degradation. In theoretical systems analysis, a military operation is a machine, and prolonged high-intensity stress produces nonlinear wear. This is a destructive feedback loop. Coordination breakdown increases logistical strain. Logistical strain reduces operational tempo. Each failure reinforces the next until the system fails. As the fog of war deepens, intelligence uncertainty expands. You no longer know where the enemy is, but more importantly, you no longer know where your own logistics are. Depth kills certainty. In the 2030 era, this uncertainty is amplified by the electronic cyber fog. Russia's deep-tier disruption systems ensure that no digital network remains stable beyond its own secure perimeter. Equipment attrition accelerates. Precision systems fail in contested electronic environments. Maintenance cycles that worked at 200 kilometers fail at 2,000. Technology becomes a liability. At a certain threshold, the invading force ceases to be a unified strategic system. It fragments into isolated units struggling to survive. This is the transition to a containment problem. Containment in this environment is a trap. You are holding territory, but the territory is holding you. You are pinned by geography, unable to advance and unable to retreat. This is where invasions die. Even the massive industrial machine of the 1940s could not sustain the cost of this depth. The system degraded until the front collapsed from the exhaustion of every supporting pillar. And we must never forget the shadow of escalation. In a modern era, any threat to the national survival of a nuclear power invites existential risk. This risk is not linear. It is a wall that stops conventional logic. When all factors are combined, scale, logistics, environment, electronic warfare, nuclear risk, economics, and politics, the result is not a difficulty. It is a structural condition of non-viability. Tactical success is always possible. Battles can be won, cities can be taken. But sustained strategic success requires stability across too many independent and hostile variables simultaneously. Depth is the ultimate countermeasure. In modern warfare, complexity is a weapon. When complexity exceeds control capacity, outcomes are no longer determined by strength. They are determined by endurance under uncertainty. In this dimension, the balance becomes fundamentally unstable for any invader. The land itself, with its distance and its silence, remains the ultimate victor. It is the unconquerable land. This concludes our investigation into the structural impossibility of invading Russia in the 2030 era. A land defined not by its borders, but by its depth. Thank you for joining us. As technology evolves, the tools of war change, but the physics of the earth do not. The lessons of history remain etched into the soil. For more in-depth analysis, subscribe to our archive. Produced by HeyGen Video Agent, narrated by the Voice of Analysis. Visuals inspired by the Archive of History. Part 2 of 2. Finished. In modern warfare, complexity is a weapon. When complexity exceeds control capacity, outcomes are no longer determined by strength. They are determined by endurance under uncertainty. In this dimension, the balance becomes fundamentally unstable for any invader. The land itself, with its distance and its silence, remains the ultimate victor. It is the unconquerable land. This concludes our investigation into the structural impossibility of invading Russia in the 2030 era. A land defined not by its borders, but by its depth. Thank you for joining us. As technology evolves, the tools of war change, but the physics of the earth do not. The lessons of history remain etched into the soil. For more in-depth analysis, subscribe to our archive. When we summarize the strategic reality, the conclusion remains the same. The land itself is the primary obstacle, and its depth is the ultimate defense. Produced by HeyGen Video Agent, narrated by the Voice of Analysis, visuals inspired by the Archive of History, Part 2 of 2, finished.